Good morning. In this video, we are going to discuss about uniform motion. In uniform motion, the acceleration remains constant throughout the motion. Actually, we discussed about this motion in my previous video, and now let us go and discuss that again. So this is constant acceleration or uniform motion where acceleration remains constant, and these three are the formulas: v equal to u plus at, s equal to ut plus half at square, v square equal to u square plus 2as. Moreover, these are the parameters are used: final velocity, initial velocity, acceleration, time and displacement. So with the help of this relationship and these variables, we are going to see the problems. Now let us go to the problem. A train starts from rest and accelerates uniformly. You just note that the train starts from rest and accelerates uniformly. Okay, these two are very important information. At the rate of 2 meter per second square for 10 seconds. If it then maintains a constant velocity, note this word also, constant velocity for 40 seconds. On applying brakes, the train is uniformly retarded. Note this word retard, and stops in 20 seconds. Calculate the maximum velocity, retardation in last 20 seconds, the total distance traveled as well as the average velocity. Now let us understand this problem well. There are three types of motion in sequence. First one is uniform acceleration, where a equal to constant, and that motion starts from rest. Okay, that exists for 10 seconds. After that, there is a constant velocity for 40 seconds. Constant velocity, note that one. After that constant velocity, there is a uniform retardation. Uniform retardation is nothing but similar to constant acceleration, but here the velocity will be decreased. Okay, so retardation or deceleration, both are same. Okay, that will work exactly in opposite way to the uniform acceleration, and at the end the train stops. Now you have to find four important things: maximum velocity, retardation, nothing but deceleration or acceleration, then total distance, okay, by the three motions, then average velocity. Now let us go and solve the problem. The first step in solving this problem is drawing the motions in VT graph. That means V in the y-axis and T in the x-axis. You see here for the first 10 seconds, okay, the motion is constant acceleration. Okay, since it is a constant acceleration, the velocity starts from 0 and it increases, finally it attains the final velocity. After that one, there is constant velocity motion, okay, for the 40 second. Okay, so when I say constant velocity, suppose if the velocity is u2, this u2 remains constant throughout this motion for 40 seconds. After that, there will be a retardation, okay, where the velocity will be decreased, okay, with the help of acceleration, and that will exist for 20 seconds. Okay, so this is the VT graph that shows that represents the motions. Okay, so this is a very important thing. Now let us go and first take the first motion, constant acceleration. This is the first motion, constant acceleration. The train starts from rest, and using constant accelerated motion, the velocity will be increased. Constant acceleration, let me take for example a equal to 1 meter per second square. In that case, the velocity will be increased by 1 meter per second for every 1 second. If it is 0 at the start, then after 1 second, velocity will be 1 meter per second. After 2 seconds, velocity will be 2 meter per second. Okay, so this is the way of incrementing the velocity with the help of constant acceleration. Now let us go and discuss this constant acceleration motion. At first, initial velocity u equal to 0. Okay, because the train starts from rest, so it is represented here. From rest means the velocity value will be 0. Next time t1 equal to 10 second, it is given, right? Acceleration a1 is equal to 2 meter per second square. This is also given in the problem. Okay, but you have to take this data alone, right? Now let us go and use the constant acceleration equation. Already we discussed that there are three equations. Now I am going to use the first equation, v1 equal to u1 plus 80. Now u1 is 0, so from this one you can get the answer for v1, which is equal to 20 meter per second. Then using the second equation, s equal to ut plus half a t square, this time will become 0, and just substitute a equal to 2 and t1 equal to 10. Now you just get the answer for s1, which is equal to 100 meter. Okay. Now let us go to the second motion. Now in second motion, the velocity remains constant. That's what that graph shows. So this is the constant velocity. Okay, you see here v equal to constant. Now let us go and see the corresponding formula for this motion. So this is constant velocity, and you see here the formula is s equal to u into t, where u is nothing but velocity, t is time. Now let us go back to the problem. Now let us go to the problem. Initial velocity, okay, for the constant velocity motion, the initial velocity is represented by u2, since the velocity remains constant, which is nothing but v2. Okay, u2 is equal to v2. This is the important thing. Next, if you could look at the graph, so here, so this is u2, let me take this one is u2, but u2 is the final velocity for this motion. Okay, here u1, here v1, but at this point v1 equal to u2. Okay, so u2 can be equal to the v1. Okay, we know that v1 is equal to 20 meter per second. So u2, which is equal to v2, and which is again equal to v1. This is very important thing we have to note. Next one is, since constant velocity a2 is equal to 0, the corresponding time t2 equal to 40 second. Now as we see, the formula is s equal to u into t, and you just substitute the value of 20 for u2 and 40 for t2. Finally s2 can be found as 800 meter. Now the third one is constant retardation or deceleration, where the acceleration is constant, but the acceleration will reduce the velocity of the object. Now let us go to the graph again. So this is the third motion, constant retardation, but this motion starts at the end of the constant velocity. Now v2, if you take this as v2, now this v2 is the initial velocity for this motion. So v2 can be taken as equal to u3, and moreover here you see here the train comes to rest, so the final velocity v3 can be taken as 0. So this is very important thing to note from this graph. So this is what here it is written: initial velocity u3 equal to v2, which is again equal to 20 meter per second. Final velocity v3 equal to 0 because the train comes to rest. Now the total time taken is t3 equal to 20 second. Now by using the first equation, v3 equal to u3 plus a3 into t3, now we know that v3 is equal to 0. Okay, so a3 can be found as like this one, which is equal to minus 1 meter per second square. Now using s equal to ut plus half at square formula, you just find the value of s3 and substitute a3 equal to minus 1 and u3 again it is 20, t3 equal to again 20. Now s3 is found as 200 meter. Now let us come to the answer spot. The maximum velocity throughout this motion is 20 meter per second, and the retardation in the last motion is a3 equal to minus 1 per meter per second square. Now the total distance traveled, okay, so you have to add the distance in each motion. So s1 plus s2 plus s3, which is equal to 1100 meter. Next one is the average velocity, v average, and you know that this is the average velocity in the first motion, this is second motion and third motion, and finally you get the answer for average velocity is 10 meter per second. Thank you. We will meet in the next video.